All right, in chapter 1, we learned how to get our samples using different sampling techniques. Now we're going to talk about, now that we have a set of data, how are we going to get it organized? How can we get it in a way that we can see what's going on? How is the data distributed? Now this first section, 2.1, has a lot of information, so I really don't think I'll get this in one 10-minute video. Probably 2, maybe even 3. But what we're going to do is we're going to look at this one example, and we're going to use this one example to illustrate everything in Chapter 2, Section 1. So Professor Hill in the music department kept a list of the number of students visiting his office each week for 2 semesters. The results were, so we have, 15 students visited one week, 20 another week, 9 another week, and for 30 weeks. And the first thing we want to do is get our data organized, and we're going to do this in a frequency table. Now what a frequency table does is it splits our data up into groups or classes. Now all of the problems will tell you how many classes to use. We're going to make a frequency table with 5 classes. So we're going to split these 30 semesters into 5 groups. Now the first thing that we have to do is figure out what values go into what group, and that's called the class width. Okay? Now the formula for class width in your notes was to take the largest data value minus the smallest data value and then divide by how many classes. So let's look at this set of data. What's the largest data value? 32. Minus the smallest data value, which is a 3, and we want to use 5 classes. So we're going to split this into 5 classes. So 32 minus 3 is 29, and 29 divided by 5 is 5.8. Now, clearly, you cannot have 5.8 as a class width. It needs to be a whole number, So we always round up. No matter what, round up to the next whole number. So 6 is our class width. If we had gotten 5.001, you would still round up to 6. In fact, if you had gotten 5 exactly, you would still round up to the next data value. If you don't, then your largest data value isn't going to be able to show up on your class limits, okay? All right, so we've got our class width. Largest data value minus smallest data value divided by the number of classes, rounded up to the next whole number. All right, to get our class limits, we start with the smallest data value, which is a 3. Now, we want 6 values here. We've already got a 3, so we need 5 more. 3 plus 5 is 8. So our first class limits are going to be 3 to 8. If you think about it, you've got 3, 4, 5, 6, 7, 8. That is 6 values. Okay. Now when we go down to the next one, we ended at 8, so it's going to start at 9. If you notice, 3 plus our class width of 6 is 9. So if you want to think about on our way down, we are adding 6. You could do it that way. Okay? In fact, we can do that. 9, and then 9 plus 6 is 15. 15 plus 6 is 21. And 21 plus 6 is 27. So this one starts at 15. This one has to end at 14. The 4th class starts at 21, so the 3rd class has to end at 20. The 5th class starts at 27, so the 4th class has to stop at 26. Now if you notice, we're adding 5 here. 3 plus 5 is 8. 9 plus 5 is 14. Okay, plus 5 plus 5. So 27 plus 5 is 32. Or, we were adding 6 down this way. You can also add 6 down this way. Lots of little ways to remember how to get your numbers on your class limits. It's very important to get your class limits correct because the rest of the table is based on your class limits. and then also we get all of our graphs from information in our table, so we have to get started right. So you start with your lowest data value. Now when you get to the end, this problem did end with the highest data value, but that's not necessarily going to be the case, okay? You must start with the lowest data value. Your highest data value should fall somewhere in this last class, but not necessarily, it's not necessarily going to be the ending point. All right, now the problem with our class limits is that there are gaps from 8 to 9. You know, where's 8.2? Where's 8.7? Okay, there's a gap there. And when we're making our histograms later, we can't have gaps. The bars need to touch. So what we do to take care of that on our class boundaries is on the lower class limit, we go down a half, which means from 3 we would go down to 2.5, and from 8 we go up a half. So that would become 8.5. So 2.5 to 8.5. Same thing here. When I use 9 and I go down a half, I'm at 8.5 up to 14.5. Okay, and then 14.5 to 20.5, and then 20.5 to 26.5, and then 26.5 to 32.5. Okay, so just down a half, up a half. Now there's no gaps. We have 8.5, 8.5, right? 14.5, 14.5. No gaps, so when we get to our graphs later, we'll be fine. All right, midpoints, we just want the middle of the class. So if it's going from 3 to 8, how do you get the midpoint? Well, to get midpoints, you would add your class limits, so 3 plus 8, and then divide by 2. So 3 plus 8 is 11, and 11 divided by 2 is 5.5. Okay. All right. And then our next class is 9 to 14, so we're going to go 9 plus 14, which is 23, and divide that by 2, and we get 11.5. Same thing on the third class, 15 to 20. When we add that, we get 35. 35 divided by 2 is 17.5. Fourth class, 21 plus 26 is 47. 47 divided by 2 is 23.5. And then 27 to 32, 27 plus 32 is 59. Divided by 2 is 29.5. Now, what do you notice about the difference between our class widths? Our midpoints, it's 6, our class width. So the class width pops up again, okay, our midpoints. If our class width had been 12, our midpoints would go by 12, okay? All right. I think this is a good stopping point before I reach my 10-minute mark. You're going to need to start up the part 2 for this to get the rest of the table.